Hello everyone. So we are continuing with lecture number 7. We were discussing the part number 2 or case number 2, that is we are interested to find out the electric field which is located at the points on the equatorial plane, and this topic is given on page number 28 in your book. Okay, page number 28. Okay, so let us recall what was the point on a equatorial plane. So you consider that this pencil is the axis of the dipole, and you can consider that we have one positive charge over here and a negative charge over here, right? Okay, then what is a equatorial plane? So you consider that this card is a equatorial plane. So ये जो प्लेन बन रहा है 90 डिग्री का एंगल बन रहा है, एंड दैट इज व्हाट इक्वेटोरियल प्लेन इज, एंड द पॉइंट कैन बी लोकेटेड एनीवेयर ऑन दिस प्लेन. वो कहीं पे भी हो सकता है, कहीं पे भी हो सकता है, राइट? ओके, सो लेट अस कंटिन्यू. सो व्हाट वी हैव टू डू, सबसे पहले हमें डाइपोल्स दिखाने पड़ेंगे, राइट? वी हैव टू शो द चार्जेस. ओके, सो यहाँ पे विल शो माइनस क्यू, दैट इज वन चार्ज, एक चार्ज ये हो गया, राइट? एंड देन वी हैव अनदर चार्ज विच इज प्लस क्यू, राइट? दिस इज द फर्स्ट स्टेप. कोई भी न्यूमेरिकल हो डाइपोल का या फिर एनी थियरी इज देयर, सो यू हैव टू स्टार्ट विथ शोइंग द चार्जेस. Second thing is you join or partially show that the line which is joining the two charges. Okay, so this is the line joining the two charges. Okay, and then after you have to show the direction of the dipole. So if you remember, what we discuss is the direction of the dipole is always from negative charge to the positive charge, or it is always from minus q to plus q, and that means that this is the direction of the dipole. It is from minus q to plus q. Then next thing is you have to show the center. So let us say this is the center. Okay, and we also have to show the distance between two dipoles. So what we know is the distance between two dipole is 2a, right? Okay, so this is the basic thing for any dipole numerical or a theory. This has to be there. Now our point P is located on the equatorial plane. So over here I have draw one equatorial plane. Okay, equatorial plane is there, and in that equatorial plane we have a point P. We have a point P which is shown by a pink dot, right? Okay, so this is how you have to show it. Now we are interested, obviously the P point will have effect of both the charges. Plus Q will have its own electric field working on point P. Minus Q charge will also have electric field which is working on point P, and we are going to find out the combined effect, vector sum of these two on point P. But सबसे पहले सुपरपोजिशन के हिसाब से हम we are going to find out only one electric field due to only one charge. Okay, so let us start with the plus Q. Okay, so क्या डिस्कस किया था? If we have a positive charge, then the electric field lines has to be outward, normal. Okay, तो ये outward direction में field line draw करनी है, and हम किसके ऊपर फाइंड कर रहे हैं? वी आर डूइंग इट विथ रिस्पेक्ट टू पॉइंट P. ओके, सो व्हाट आई विल डू, आई विल ड्रॉ अ लाइन which is joining the plus Q charge and the point P. Okay, right? Okay, and then after you can understand that there will be some force which is electric field lines which will be there, and here is its direction. Okay, it is plus Q, say it is outward, it is outward, right? Okay, so I will denote this with E electric field E, okay, and it is due to charge plus Q, right? So it is E plus Q. Done? Okay. Then after, I will write down its equation. But before that, let us consider that the angle which is made over here is theta. Okay, the angle which is made over here is theta, and let us say the center of the dipole is to be denoted by O. So, why I am doing this? Because I want to calculate the E plus Q. Over here it is अभी मैंने वेक्टर नहीं दिखाया है, ठीक है, it is just a magnitude. I just want to calculate the magnitude. Okay, so to calculate the magnitude, again I have to use my old equation to find out the electric field. So what was it? It was 1 upon 4 pi epsilon 0 Q upon R square, right? This is just magnitude, no directions are there, this is just magnitude. So same equation I'll try to bring it over here. So I will put 1 upon 4 pi epsilon 0 over here. Then after, the capital Q is there, so that is to be replaced by Q. Okay, only magnitude is to be written, okay, no sign. Okay, then after, what is R square? So R square is the distance between the charge and the point, right? So over here plus Q और P के बीच में कितना distance है, that I need to find out. So for that we have made this arrangement. Again this figure is redrawn over here. देखो यहाँ पे ये plus Q है, so this is plus Q. Then after, this is point O, so this is point O. It is in the center, इसीलिए यहाँ पे ये distance है वो 2a by 2 होगा, so that is a, right? Okay, and then after we have O to P distance which I have taken. P point is R distance away from the center of the dipole, right? So that is what R distance is in this case. Okay, so उसके हिसाब से प्लस Q एंड पॉइंट P के बीच में कितना डिस्टेंस रहेगा? सो फ्रॉम पाइथागोरस थियरम वी कैन इजीली कैलकुलेट दैट द डिस्टेंस कैन बी गिवन एज a square root of a square plus r square. So I am just writing that it is a square plus r square and then its root is there, right? Okay, so यहाँ पे मैं directly लिख रहा हूँ it is a square plus r square, right? Okay, then after over here you will see that this is just a distance and then after again it has been squared. So I am squaring it. So this is like raised to 1 by 2 और उसका square होगा. So finally I will get 1 upon 4 pi epsilon 0 Q a square plus r square, right? Okay, clear है सब? Okay, so now let us talk about E minus Q. So for E minus Q, again I have to draw the field lines. Okay, if you remember, when we have a negative charge, then the direction of electric field lines is inward. Okay, so over here there is a negative charge, this is negative charge, and I want to find out its effect on point P. So I will draw a line which is joining the two. So this is the line which is joining the two, and the direction of electric field is towards the minus Q. So I will show that this is the electric field vector, this is the electric field vector, and its magnitude is E minus Q. It is E minus Q, right? So this is how we have two vectors. यहाँ पे मैं थोड़ा सा इसको बड़ा करके दिखाता हूँ. So this is point P. We have a electric field vector E plus Q. Over here we have another electric field vector acting on it, which is E minus Q. What do you think? इन दोनों का मैग्नीट्यूड सेम होगा कि नहीं? Yes, it will be same. Why? Because as you can see, P is symmetrical to both plus Q and minus Q. These two charges are having equal value. तो P point पे दोनों की इफेक्ट है वो सेम रहेगी because they are at a equal distance, right? Okay, so that is how you have to show both the vectors with equal lengths. So please take care of that, right? Okay, So let us write down the equation for E minus Q. So again I have redrawn the figure. So we have point P over here, तो मैंने भी यहाँ पे P point बनाया है. Then after O point is there, so that is O point. Then we have a distance A over here, so that is A. Then we have a minus Q charge over here. So again you apply the Pythagoras theorem, and you can easily say that this hypotenuse is root of a square plus r square. Again you use the same equation to find out the electric field, and what you can write is 1 upon 4 pi epsilon 0. No need to write down the sign over here, we are just talking about the magnitude only, so that is I have shown it with q only. And then after, the distance is a square plus r square, right? Okay, so if you compare both the charges magnitude wise, then both will have same value, दोनों की वैल्यू है वो सेम आ रही है, right? Okay, now what is the next step? नेक्स्ट स्टेप में हमें क्या करना है कि इन दोनों को ऐड करना है. नाउ इट इज लाइक वी हैव टू वेक्टर्स एंड वी नीड टू फाइंड आउट इट्स रिजल्टेंट. ओके, सो before we proceed, I would like to revise some vector fundas. Okay, so